Okay. There we go. It looks like we're recording. And it's 12 o'clock, so we'll get started. Welcome everyone to this presentation of a really cool proof of concept that was developed by Roger Cleaves of the Department of Toxic Substances Control. And I've seen this demoed at a couple of other meetings, and in fact, Esri is using this application in their video that they have posted on this product, ArcGIS Velocity. We did invite one of the product engineers for ArcGIS Velocity to join us, and her name is Suzanne Foss. So she'll be available to answer hard questions on the technical side that to make sure y'all get your questions answered. So again, those of you who are joining, please type your name in the chat, just so we have a record of who attended. And now I would like to introduce Roger Cleaves. He's an information technology specialist with Department of Toxic Substances Control. And this is a really cool application. So I'm just going to turn it over to Roger. Go ahead. Thanks.
Thanks, Jane. Hi, all. As Jane said, I'm Roger Cleaves. I've been with the state for about 5 years, working in IT as the information technology specialist, but focusing mainly on GIS applications and the Esri suite of products. Our department wears many different hats, and one of them is hazardous waste tracking for the state of California, both waste coming from out of state, into the state, out of the state, whether that's internationally or to other neighboring states. And we have a custom home-built internal system called HWTS, or the Hazardous Waste Tracking System, that we've recently kind of started putting a fresh face on and kind of revamp. And one of the things we're looking at is spatial analysis using it. And so if you have any questions throughout this, feel free to throw them in the chat. I'll try to answer them at the end, or you can wait till the end and you can just raise your hand and ask them. I'm fine. I'm here to answer any and all questions regarding this and our implementation and our proof of concept, really, with Velocity. So with that, I'm going to go ahead and start the presentation. So our current state is we're kind of in a quasi state with our department, where historically we received paper manifests for every piece of hazardous waste manifested and transported throughout the state of California. A lot like the one you're seeing on the right. Actually, the one on the right is, if you know EPA IDs, you can look in that section 14 in the middle. Actually says OR. So this is an example from the state of Oregon, but it's a federal form and a federal standard for manifesting hazardous waste. And historically, we received paper copies. And we had a company that would go ahead and transcribe that data, do double key entry, and then we would get it about 6 months later. With the newest system that the EPA has rolled out, it's the federal e-manifest system, where hazardous waste transporters, generators, and TSDFs, which are treatment, storage, and disposal facilities, can actually submit electronic versions of this data and then process through with it. So it shortened our delay from 6 to 9 to 12 months of getting this hazardous waste information into our system to about 3 months. I would say now we still get data probably about 3 months late. So we can't give real-time updates to what hazardous waste is. But the reason we kind of want to open the can of worms with Velocity was we wanted to try it out and see if we could very easily move the department, move the state towards real-time tracking of hazardous waste. There's a lot of benefits for it. I'll get to it as we move on, but we wanted to see what would be feasible and possible. And so, working with Esri last year, we took a day's worth of manifests, and I think there were about 1,700 or so individual manifests. I think the date was July 13th, 2019. So that can kind of give you an example of how much waste is traveling throughout the state. And actually, I'm gonna go back to this, just the points, right? So now we're looking at a couple different data sets here. The pink locations, the pink squares, are hazardous waste generators. Those are facilities that generate hazardous waste. They could be refineries, they could be huge chemical plants, they could be a school that has some oil, or it could be your Walgreens that has old medicine that they're trying to get rid of. So we track all of this data coming in, and then the green boxes are TSDFs, treatment, storage, or disposal facilities. And obviously generators are transporters are the ones that sit in between them and handle the waste, take it from point A to point B. There's some subtleties that how hazardous waste is transported in the state. Sometimes it's combined with other types of hazardous waste and we'll create a new manifest. So it gets very complicated, but on the surface, that's kind of how the hazardous waste tracking works in our state. So we took 1,700 individual manifests and we said, let's create points for all the generation, locations, all the TSDF locations, and let's see where they are spatially distributed. So as we can see, they're all over the place, right? And the TSDFs are usually located in pretty central areas, industrial areas, larger population centers, but sometimes they're not. Sometimes there's specific landfills that can handle hazardous waste that are located out in Central Valley or somewhere like that. So the next question we want to ask, where did the waste actually go? Let's just point A to point B, draw me a line. Let's see what it looks like. And so this was our first dive in, and this doesn't even touch on what Velocity can do yet. This was just kind of doing our first in-depth look at the hazardous waste transportation throughout the state. And the first thing we noticed was there's a lot of waste going from one end of the state to the other end of the state when there's definitely a closer location they could try to send that waste. Now, there's a lot of subtleties to different types of TSDFs. Some can only accept certain waste, some can't. But in general, there's usually a TSDF nearby that can accept that waste. So why is so much waste traveling so far, right? Why that's a lot of time for hazardous waste to be on the road that could potentially get in an accident or go too close to sensitive receptors. Other people can get exposed to it, and we don't really want that, right? So the next question was, obviously they're not flying on the back of an eagle across the state, right? Let's do some routing. Let's throw it on some streets and see in general what we've got. So we decided to go ahead and build some very generic routing into this using another Esri tool, Network Analyst. And I mean, the first thing that stands out is it's a lot of individual routes of that waste. And I mean, obviously they're going over some bridges that probably they don't really need to go over. So is that something that eventually we could take a look at, right? Is that something that eventually we could build in buffers or build in notifications to tell us when that happens? But the first thing we just wanted to do is let's just throw the data onto a street grid so we could simulate what these trucks would look like. And so what we wanted to do is simulate that truck travel. So with the help from the ArcGIS Velocity team, we were able to create simulated truck data for all those manifests. So we could then load that data and repeat it and pass it into the Velocity engine and have different notifications fire off. So this screen you're seeing here on the right, this is what the actual inside of HWT or the ArcGIS Velocity looks like. It's like Model Builder. It's like GeoEvent Server. I mean, basically is GeoEvent Server except in the cloud and wired up to your ArcGIS Online organization. So in terms of implementation and deployment, it's very, very easy to get this up and running, to integrate it with your ArcGIS Online organization. Much more easier than GeoEvent. You don't have to worry about a server. You don't have to worry about any of the port requirements, any of the security that goes into that. It just connects a lot easier, and it's all in Azure. So when you wanted to implement ArcGIS Velocity, they spin up an Azure cloud server, and it sits on there, and it wires directly into your ArcGIS Online organization, and it becomes one of the little buttons in your little waffle button at the top right. But it's a lot like Model Builder. You have a lot of different spatial analysis tools you can do. For this, we're doing spatial joins and throwing on some timestamps and some calculations, but you can do buffers, you can do geofencing and things like that. So it was pretty cool to get in there and play around. And from start to finish, once we had the input data of the trucks driving around, probably getting this wired up maybe took a few days, maybe not even. I wouldn't even say it took a few days. I would say it probably took like a day of playing with the different tools, learning the program, playing with the different tools, seeing which one's going to help me get to the end result the best, and then implementing it. And so in this map, and we'll zoom out a little bit, we actually have that truck data being cycled. So this is the real truck, as best as we can simulate what happened on that day when the truck picked up from point A to point B and went to the shortest route. And what we did is Esri helped us. They built a iterative data set that has a location for each one of these and a timestamp, and as it moves along, it pushes through, and then you just connect it to an ArcGIS feed layer. And this is what you see here. So if we zoom in, you actually start to see it moving a little bit faster. And you can see that this truck is going down one of the routes towards a TSDF location, unless it turned left. No, I was right. Okay. It's going to move up here towards this TSDF location. You actually already can see some trucks that have stopped here. And so the way this feed works is it just restarts over and over, but it gives us a good idea of how do we simulate those trucks traveling down those roads. So then we can actually use the Velocity engine to fire off notifications and alerts. And so here are some of these simulated alerts. In this dashboard that we built, you can see those same trucks driving along, and we wanted to look specifically at sensitive receptors. And they drive too close to public schools, private schools, urban residences, hospitals, things like that, where hazardous waste probably shouldn't be around that area for too long. So as you can see, if we go in here, there's some notifications that fired off where someone generated waste and they drove right by some schools. Maybe it was the school itself. That's going to happen. But there are some where, especially down here, there are two schools in basically the same neighborhood as a treatment storage disposal facility. So every truck that has to go there has to drive right by these schools. And depending on how many trucks that is, I probably could click and give you an idea of how many drove on this path. There were 4 routes this day that went down this way. But multiply that times 365, that's a lot of trucks traveling with hazardous waste right by these sensitive receptors. So with Velocity, what you can do is build those feeds in so as the truck's driving down the freeway and it has a buffer and it gets too close to these other feature layers, and these school and hospital layers are just living Atlas school and hospital layers. So it's not even data that I have to maintain. I can tap into publicly available data sets and it can immediately give me these alerts and notifications. And if you're familiar with the Esri product, this is just one of those operations dashboards. The other one was just one of their web apps. You're just interacting with those feeds or the services in different ways. And so, for instance, here comes a truck right here. So as it drives through, it would basically, Velocity would notice where that position was, where the school was, and it would start firing off these alerts. Now, the things that you can do with these alerts, you can send text messages, you can send email notifications, things like that. And I think that's kind of the power in it, that if something happens in real time, let's say a hazardous waste truck is traveling at very high speeds on the freeway, like normal speeds for a truck on the freeway, and all of a sudden it just comes to a dead stop. But the traffic layer is saying there's no traffic there. Well, maybe there was an incident, maybe it had an accident, something like that. We can then know exactly what waste is manifested on that truck and immediately notify first responders of how to approach that incident. Notify the hazardous waste responders that that is toxic, specific form, things that you have to do to control it. You can't just spray water on it. It could vaporize, things like that. So that was one of the ideas that we had for it as well. And so we have some goals that we built out off of this. Our short-term goals was, let's just do stuff we could already do in-house without Velocity, right? Let's just go ahead and look at travel distance evaluation of manifested data. No one has ever really looked at our hazardous waste data and said, how do I go from point A to point B, and like, where is that data, where are those trucks going? We can look at the amount of waste entering and exiting the state and the country. We can get an idea of how much waste that we're actually sending out of state and how much waste is coming in from other states. We can do the type, evaluation and hotspot analysis, where we can say, well, there's a lot of this specific type of hazardous waste being generated at this facility, and that's potentially harmful. Maybe we should think about that next time we have a generator want to, create another facility nearby. Or same for our permanent facilities, which are TSDFs. hey, we noticed that there are a lot of TSDFs in the LA area. They like 7 or 8 of them already handle this type of waste. Why am I going to approve another permit for another one if those ones seem that unless they can't handle the capacity, but why am I going to, you have to prove to me, create extra proof to me why I need to approve your permit. Or maybe there's a better spatial location you can put that TSDF facility so you can more spatially spread out the distribution of where hazardous waste is going from and going to. We can get those trucks off the road quicker. And then we had some middle term goals, which was some of that, well, I just mentioned it, spatial decision making for permitting, travel route simulation. There's a bill that was recently passed, AB 673, I think it was passed 2 years ago, where we have to give a scoring procedure for all of our permanent facilities. And one of the things we talk about is standoff distances to sensitive receptors from that facility itself. So from the XY location of that facility, how close are the local, are the schools, residential areas, hospitals, daycares, things like that. But we've never thought about like, well, what are the actual, almost like the spider web patterns of trucks coming in and out of that area, and multiply that by how many trucks per day and things like that. Well, now it almost makes it like we need to sort of build out a spatial buffer off of those routes itself, so we can prevent trucks from driving down these things. And then the long-term goals were really like, what can we do to get to the point of real-time tracking of hazardous waste? Right? What is it going to take for us to do that? And the Esri ArcGIS Velocity program, basically gives us the tools we need right now, and it can be deployed instantly, and we can build upon it in like a week or two. And as long as we have the input data, we could start tracking hazardous waste real time in the state right now. We could track any vehicle locations real time in the state. The holdup is obviously getting GPS feeds from hazardous waste transporters, right? But we're saying the technology is already ready for it, right? So it's just an issue of getting legislation passed or getting rules put in place that, hey, if you're going to be a registered transporter in the state of California, you have to provide your GPS feeds, your standard Internet of Things GPS feeds, which most of the larger transporter companies are already doing that because they're already tracking their fleets, because they're already worried about if there's spills, because they're on the hook if they spill that waste. So that's really the only holdup, right? Notifications, right? If they're near sensitive receptors, or we talked about, if they get too close to schools and things like that, fire off a notification, tell us. They're not supposed to be doing that. There may be fines associated with that kind of behavior. Notifications of trucks traveling on restricted roadways and bridges. We looked at the bridge, the Dunbarton Bridge in the Bay Area. I'm pretty sure hazardous waste and explosives cannot travel over most of those bridges. Now we can get notified instantly, build some geofences on there, and as soon as that truck comes in to that geofence, we can mark it and say, hey, you just violated, I think it's federal law that you can't drive over bridges with hazardous waste, right? Now we're going to fine you. And we don't even need any other proof other than I've got the real-time data, I've got the GPS feeds, we're good to go. Alerts to first responders if incidents occur about waste types. So we talked about that, where if a truck spills the specific type of hazardous waste, we could instantly notify the local jurisdiction's emergency responses with what's on that truck, what type of waste, things like that. Increased oversight of hazardous waste in the state. We could, maybe not real time, give this information out to the public, but we could at least provide some of this analysis and this geospatial representation of where trucks are traveling with hazardous waste in the state. So that's something we could also provide. Complete visibility of the hazardous waste transportation for generators, transporters, and TSDFs. So the other thing we talked about was this tool can also provide that transparency to those individual units as well. If I'm a transporter, I would love to know where my hazardous waste is. If I'm a TSDF, I would love to know, get like a notification an hour out, hey, this specific type of waste will be arriving within the hour. Here, that way I can prepare the equipment that I need to safely remove it and expedite and get the process a little bit cleaned up for them too. So there's multiple benefits here. And also for generators. If you generate hazardous waste, you own it forever until the hazardous waste is deemed safe to be destroyed or something like that. But basically, if you generate hazardous waste and you put it in a landfill somewhere and that landfill has an incident and there's a leak, that generator is still on the hook for that hazardous waste. So when they want to know also where the hazardous waste they just put on a truck, they want to make sure it safely gets to where it is. I think it's something that they want to know too. And so this was just hazardous waste-based workflows, and we've done some brainstorming recently on other things we can do with the Velocity engine. Real-time notifications of the hazardous waste incidents, we talked about that, but we also talked about notifying first responders, but also notifying maybe there's a spill near, a residential area, maybe send out notifications to the local jurisdiction that, hey, you need to evacuate people from that area, the standoff distances and things like that. Real-time alerts to our project managers that handle all of our hazardous waste cleanup sites. Another big thing that we do in the department is clean up old hazardous waste sites throughout the state. We wanted to be able to alert them when there's encroaching natural disasters like wildfires or floods and things like that, so that they can take the proper precautions, schedule inspections for their sites, and then also, hey, notify CAL FIRE if that wildfire is getting too close to a facility where it has potential for a large explosion. If that fire gets within there, and maybe they can put up a front before that fire gets to the facility because of the widespread damage it could cause. Clean up site debris monitoring, a lot like the trucks we talked about going between generators and TSDFs. Every cleanup site, we have trucks coming on every day, loading up hazardous waste or usually dirt, and then taking it away to a TSDF. We could do real-time monitoring with that, so project managers have more insight into the trucks that have come on my site every day and gone off my site every day, which way they went, things like that. Questions we get a lot at public meetings are, all these trucks keep driving through my neighborhood. What's in it? How do I know it's safe? Things like that. And now we can actually provide that information. Oh, it looks like 5 trucks came through today. They're all carrying soil or whatever. Emergency response safety monitoring, monitor ER staff when deployed. If they're getting too close to things that we know and we've been notified that are issues like down power lines or road access issues. A lot of times when our folks go out and do the household hazardous waste removal after wildfires, we have a lot of road access issues, trees down, things like that. This can give them a notification real quick as they're driving up on it, be like, hey, don't go this way. There's known trees that are down. There's known power lines that have issues that area. Here's alternative ways you can go, and you can fire off those notifications via text message. Or maybe there's incoming rain and floods, and you could have a mudslide on the burn scar, and so you want to get your teams out of there quickly. Hazardous waste violation notifications. Notify DTSC when transporters violate regulations regarding transport of waste. We talked about bridges, we talked about residential areas, things like that. Immediately notify our department that they just violated these things. Makes our lives a little bit easier to go collect those fees when we have proof and data saying you did indeed violate it. As of right now, we only know where they started and where they went. We don't know all the in-between. And so those were other ideas that we thought about using the Velocity engine. I will reiterate that getting it up and running and deploying it, you don't have to be technical at all. GeoEvent server, we played around with it for a while. You have to be very technical to understand how to get things working correctly in GeoEvent server, and it can be installed in the cloud, but it's essentially like an on-prem server that you have to spin up and then connect to everything. ArcGIS Velocity, you don't have to. You purchase it. They spin it up in Azure. You can buy different levels based on the amount of use that you're going to need, how many multiple feeds you need to do at the same time, and it just wires into your ArcGIS Online organization. So you don't have to maintain anything other than requesting it and making sure it's linked in. Building those drag and drop flows for different things, you can make them as big and as complicated as you want, or as simple. Mine was pretty simple, just looking at 3 different layers and when they interact. But it's very easy, drag and drop. It's way easier to use than Model Builder, I'd say. So, and it's built off the same premise. So if you're already familiar with GeoEvent, you're going to be able to jump into Velocity very quickly. And for us, we just wanted to see what this proof of concept could do, how quickly we get up and running. And I think the big key was that we're ready whenever folks are ready for us to get going with it, to be able to start providing more insight to hazardous waste throughout the state. So with that, if you have any questions, let me know.
Okay. Any questions out there?
Yeah, Dan.
Yeah, hey, this is Danny Greenwood with GWR. I'm curious about just kind of generally how you guys plan to roll out like real-time tracking of trucks. Is there going to be, or is there an initiative to put real-time tracking on these hazardous trucks?
No, there's not an initiative to do it yet, which is unfortunate. When I talked about the cleanup side of things, where we're tracking trucks coming in and off, on and off different cleanup sites that we have, we set the rules for those cleanup sites when we do agreements with the companies that are paying for it, and we can put whatever we want in there, and it gets negotiated on. So theoretically, we could start doing that today. We could start every time we have a new agreement for a cleanup site. We could say, also, we mandate that you put GPS on your trucks and then provide us the standard feed that we can incorporate into ArcGIS Velocity. But no, there's no current plan to force transporters to do this. A lot of the larger transporter companies already have this data, already have GPS trackers on their trucks. It would just be about mandating them to provide us the feeds. Or there's other applications like GPS tracking. Esri has one where they just use their phone, and I think it's called Tracker, and they have it on their phone. Everyone's got a GPS in their phone. So they could theoretically, if they wanted a quick implementation, if they're a smaller transporter, have them have an account. It's like, I think it's $50 for a tracker or something. Be like, hey, as part of being a transporter in the state of California, you have to spend $50 on this license, and you have to enable it every time you drive around, things like that. Obviously, with that, there's a potential where they just decide not to enable it and we can't track it. But so I think in theory, the real answer would be some sort of built-in GPS device on the truck to be able to track. But once you have the data, then we're off to the races.
Okay.
Any other
questions? Suzanne, I think I see you've joined us. Did you have anything you wanted to add? Suzanne Foss is the product engineer with Esri.
Hi, everyone. Yeah, no, I don't think I have anything to add that Roger didn't already cover. Very wonderful experience to collaborate with Roger and his team on this. So just happy to answer any questions anyone has.
So this is something that doesn't normally come with an Esri license, is that correct?
Right, it's a subscription as a SaaS product. So it's something that you can add on top of our ArcGIS Online SaaS, and it allows you to do real-time and big data processing for use cases like this.
Yeah, I didn't even touch on any of the big data stuff either. So
yeah, some of the big data analysis capabilities might be relevant in the work that you guys want to do prior to, having any real-time tracking actually going on. I know the manifest data is very large, and doing summarizations and analysis is something that you could do in Velocity in the cloud with very large data. I think in our prototype period, we mostly looked at proving out some of the real-time concepts, but the big data analysis is another huge part of it as well.
Okay. All right. Anyone else? Let's see.
I see two hands.
Two hands. Okay.
Mihai, you want to go first?
Yeah, hi, Roger. I'm with Caltrans, and I was just wondering what kind of data do you use from us right now, and what kind of data would you want to get from us for something like this? Since the trucks use our network a lot.
Yeah, all the data. I don't think we use any data right now. I haven't been involved with any proof of concepts or anything like that. We were actually talking about this, I think last year. We're like, I wonder if it's Caltrans that has some of this data, or if it's CHP with the way stations that they manage, So it would be great to get in touch with you more, and we can talk about what kind of data you have available and what we can do. We currently don't have the Velocity engine just because we were still in that proof of concept phase, trying to get business to get kind of excited and convinced that this is something we could do. And I think we proved our point that we can do it very quickly and very efficiently. But as an organization, we're not quite ready for that jump. But if there's ways that we can connect with you on some data needs, that'd be fantastic.
Yeah, that sounds good. And why don't we connect offline and talk more about this?
Absolutely. Daniel.
Yeah, I'm interested in maybe being able to use this with telemetry data. Maybe this is a question for Suzanne. Has this been used with telemetry data?
With like real telemetry data from vehicles?
Yeah, or like we deal a lot with fish with telemetry. So yeah, like tracking movements of species or whatnot.
It hasn't been used, I think, with tracking movements of animals, but it absolutely has been used with telemetry data from various places. We just also added a connector for our March release to bring in vehicle telemetry data from Verizon Connect Reveal, for example. So vehicle tracking is absolutely a primary use case for the product.
Thanks.
Fish tracking sounds awesome.
Okay. All right. Anyone else? Okay. Well, thank you, everyone. I will post this recording on the GIS Council website. I just want to acknowledge that, again, this was brought to you by the GIS Council and with some help from the California Geographic Information Association and the California ERISA chapter. I put all those links in the chat. Please check them out if you're not already familiar with these organizations. And when you visit the GIS Council website, please register in there, and then we will be able to keep you informed of future events and meetings. I'm still working on getting the meeting notes from last week's meeting up there, but we're working on that. Last call for any questions. If not, we'll give you the rest of your lunch hour back. And give a big thanks to Roger. And thank you, Suzanne, for joining us. And Roger, I know you've got another presentation in about an hour, so I think we'll close this for now. And thank you, everyone, for joining us.
Yeah, I also threw my email in the chat, so if anyone has any questions or comments or anything like that, please send me an email. I'm always available and ready to respond. So thank you so much.
Okay. Thanks. Have a good day, everyone.
Thanks all.
Thank you.
Bye.